We can learn so much by looking to the history of our planet. By studying the fossils and the chemistry of the rocks laid down in Devonian oceans, we can clearly see that reef ecosystems were decimated during this time. We can piece together how things like oxygen levels in the ocean and climate conditions above the water changed this event, and connect these to changes in reef communities. By reconstructing what conditions were like leading up to and through this extinction event, we can better understand how our modern reef ecosystems might react to changes in the environment. 365 million years ago, there were many areas in the world's oceans that were anoxic or had severely reduced oxygen levels. While we do not see these conditions in our oceans today on the scale that they occurred in the Devonian, we are seeing an increase in anoxia in coastal waters. These conditions in modern environments are often associated with increased nutrients dumped into the oceans. Nutrient-dense runoff can be sourced from agriculture, sewage, or other man-made waste. This influence of nutrients, or essentially food, results in an explosion of algae in the surface waters. This dramatic increase in the amount of algae has a number of negative effects. The algae uses up all of the available oxygen in the water, and it impacts all marine life in the immediate area, causing anoxia. Coral reefs are incredibly sensitive systems. In order to thrive, their environment must be relatively stable and consistent. By studying the environmental stressors of today, we have a bit more insight of what would have led to the demise of coral reefs of the past.
What caused the late Devonian mass extinction? We don't know for sure, which I think is really exciting. Although we don't have the answer, we do know the questions to ask. Just like a crime scene investigator, we need to approach this particularly tricky mystery from all sides and at all scales. We have the tools to recreate conditions in the oceans 365 million years ago, using patterns in the layers of the rocks, hand samples, and even signals preserved at the atomic scale. We need to look at the evidence collected from different environments, and this can take us all around the world. We then head to the lab, roll up our sleeves, and try and tease out which signatures are directly linked to the extinction. Geologists have been investigating Devonian age rocks for a long time. It has been established that the world was cooling off over tens of millions of years, and this was a time of climate change. This was when the first forests were established, and certainly increased size and abundance of plants changed the chemistry of both the atmosphere and the ocean. We know from research that volcanism on a massive scale, or even asteroids, can result in mass extinctions. Using techniques like geochemistry, pyrite framboids, trace metals like molybdenum, and even the specific fossils preserved can help us eliminate potential causes of extinction and narrow down the possible triggers for the mass dying 365 million years ago. We have laid the foundation to crack the case. Now let's get to work.